All right. We want to use inference to make decisions. And when you do, sometimes you're wrong. Okay. So we're going to talk about type 1 and type 2 error and another thing called power. All right. So an error is when you make a bad decision. All right. When we make a decision based on a significance test, either we reject or we fail to reject, we hope we're right, but we may be wrong. And we have no way of knowing if we're wrong unless we do many, many tests and find out that the true mean is actually different or is actually really close to what we thought it was. We if we knew that we were about to be wrong, why would we have bothered testing? Like, if you know that you're wrong, don't bother with a test. You already know you're wrong. Okay. But what we need to talk about is the two types of errors that we make. Okay. And my way to remember which one's which is type 2 is when you fail to reject. Okay. So if you've rejected a null hypothesis and you're wrong, means that you should have not rejected it. Means that the null hypothesis was true. So if you've rejected, that's a type 1 error. If you type 2 fail to, if you fail to reject the null, but you should have, it means that it's false, but you just didn't have enough evidence. Okay, that's type 2 error. Okay, sometimes we get a rare freak sample. We reject the null when it's actually true. That's type 1 error. Or we might fail to reject when it's a truly false claim. That's type 2, fail to. All right, let's look at an example that I think encompasses this very well. Okay, so you guys know the boy who cried wolf. All right, so the null is the status quo. It's what you would normally expect. There's no wolf. Alternative hypothesis is there's a wolf. The type 1 error is the boy cries wolf. I guess that would now be the null is, oh, he's saying wolf and we're going and chasing him. And we go and then we find out that the boy was lying. Okay. Type 2 error, you failed to believe the boy because he lied to you twice already. You ignore his calls for help. So we fail to reject the null of no wolf. Okay. The boy's evidence of crying wolf, we believe it, and he was lying. That's type 1 error. Type 1 error. Okay. We're like, there's only a 5% chance that someone would cry wolf when there's no wolf. Okay. So we believe it. We'd say that's sufficient evidence to go rescue the boy. And we were wrong because he was lying. Okay. That's a type 1 error. Type 2 error says you failed to believe the boy. Fail to reject the null of no wolf because twice lied to. Okay. So we ignore and we fail to reject the no wolf null in favor of going to rescue the boy from a wolf. And because we fail to reject that, he gets gobbled up by a wolf. Okay. So we'll talk more about it. The last thing we want to discuss from this unit, though, is the probabilities of type 1 and type 2 error. Okay. Notice these are written as if-then statements. Okay. If the null is true, then you're either correct and you fail to reject the null, or you make a type 1 error and you reject a true null. And the probability that you would reject is your alpha level. Okay. In the long run, you're going to reject alpha true nulls. Alpha percent of the time, you're going to reject the null. Okay. The probability that I make a false conclusion is my p-value once I have it. Okay. But the probability in the long run of a type 1 error, alpha level percent of the time, you will make a type 1 error. And the other one minus alpha, you will make the correct conclusion and fail to reject if the null is true. If the null is false, you can't make a type 1 error. Because if you reject, then you have made the right choice. And if the null is false, then you, if the null is false and you make a type 2 error because you fail to reject a false null, okay? And that probability is called beta, okay? So alpha and beta, 1 and 2. Oh, probability of type 2 error. Ugh, that was bad typo, okay? So power is 1 minus beta. It's the ability to detect a false null hypothesis. All right. And this varies depending on alpha level, right? Because if I do a really small alpha, then I will fail to reject more often. in which case I will make lots of type 2 errors because I'll fail to reject a false null. But if I make a alpha of like 0.10 or 0.25, then I'll reject the false null all the time, okay? And so I won't make type 2 error, I'll demonstrate power, okay? It's also sample size. A bigger sample size makes it easier to detect a false null and how far the true parameter is from the claim. So like basically what we're picturing here is if the null is false, it means that the mean is somewhere else. So here's the null mean, and here's my distribution. That's my sampling distribution. And if this is the true mean, then lots of the samples, right? If this is my rejection region, lots of samples that you get within here are going to show up as failed to reject, okay? But all of these samples over here in my distribution are going to be rejection, and that's power. All of these are the good samples that allow me to reject. That's the power. All of these are my fail to rejects. That's my beta, okay? So you see that they add up. Now, if I have a true parameter that was way over here, let's say, then his distribution looks like this. What's the probability that I'm getting a sample way over here? Almost zero. That's my betas, and this is my power, okay? So a farther away true parameter is easy to detect. Larger sample size. Larger sample size basically makes this taller and skinnier and this taller and skinnier. And notice what just happened to this space. It just got way smaller, okay? And so that makes it easier to detect. And an alpha level moves this line of rejection region, making it easier or harder to detect. So power is the power to detect a false null, okay? And so you want to learn that. Now, there are mathematical ways to calculate power and beta. All that you need to know is that beta and power are complements, that power is 1 minus beta, okay? This, you said at the beginning, so that's easy. And then beta and power add up to 1 needs to be the second part that you know. You don't need to calculate power from scratch. It can be done, okay? But we don't have to in AP Stats. So that's it. Good luck with this unit and farewell.